Good morning, everyone. Thank you for joining us on our next Cscape 10 webinar. So the topic today is program downloads. We'll go straight into the video, and if you have any questions, we can get to those at the end.
Hello and welcome to today's webinar. Today we will look at Cscape 10 program downloads. Let's look at our agenda for today. We will start by reviewing how program downloads and variable values are handled in Cscape 9. We will discuss both retentive and non-retentive variable types, how register mapping works, and what happens to register values before and after download. Then we will look at the improvements made in these areas for Cscape 10, specifically in the elimination of variable value mismatches and global variable initialization. We will then finish with a Q&A session. We will start our Cscape 9 review by looking at the different OCS register types that make up the structure of OCS program memory. In most logic languages supported by Cscape, variables created by system designers are ultimately mapped to these memory types, either manually or automatically. The top 3 data types highlighted in this table are the most frequently used register types for user variables in the program. %R memory is word type memory that is used for integer, double integer, and real variables. %M is used for retentive Boolean variables, and %T is used for non-retentive Boolean variables. Also in this list, we have register types dedicated for real-world I/O and system variables. For register-based advanced ladder, the mapping of variables to OCS register space is done manually, and every variable that is created must be mapped by the user. In the ladder screenshot shown, we've highlighted variable names or I/O names in blue and the register locations in yellow. We can see that every variable in the program has been mapped manually by the user. For variable-based advanced ladder, most variables are mapped automatically by Cscape in the background, and only some variables need to be mapped manually by the user. These exceptions include real-world I/O, where specific I/O terminals need to be mapped to specific variables, as well as variables that are shared over a network, such as Modbus TCP. In variable-based logic, manual mapping by the user is performed using the program variable window and by filling in the mapping column. For example, variables mapped to real-world I/O registers, such as %I or %Q registers, are created in the global variable section of the program variable window by filling in the mapping column with the specific memory address for that variable. Now we will look at the automatic mapping Cscape performs in the background for variable-based advanced ladder. First, we will look at the rules for this process. Cscape skips any register address that the user has assigned manually. These register locations are now reserved and won't be a part of the automatic mapping process. Cscape starts with variables created by the user as global variables. In addition to the manually mapped real-world I/O type variables, global variables also include non-retentive Boolean variables. So these are mapped to %T register space, which is the non-retentive memory type. The mapping is performed starting at the lowest available register address, which is usually T1. The mapping is performed in the order in which the variables are listed in the program variable window, not in alphabetical order. Any global variables with an integer, double integer, or real data type are mapped to %R memory. These are mapped by Cscape in the order listed, starting at the lowest available address, which is usually R1. Cscape then moves on in the mapping process to retained variables. Retained Booleans are mapped to %M, and all other data types are mapped to %R. This mapping process occurs every time an error check is performed, whether the error check is triggered manually by the user or before a program download. Next, we will look at what happens to register values when an OCS controller is placed in stop mode, run mode, and on a power cycle. Here we are referring to the registers specifically, not the variables that are mapped to them. When an OCS is placed in stop mode or it loses power, all register types, including non-retentive register types, maintain their values. When the controller goes back into run mode, any non-retentive register types are cleared, and the only retentive register types hold their previous value from before the download or before the power cycle. With Cscape 9, the value of a variable on run mode or during power-up is dependent on the register location it is mapped to at the time. With Cscape 9, this means if variables are added, deleted, or remapped in between downloads, then variables can accidentally be mapped to different register locations after a download. For variables mapped to retentive registers, this means that mismatches can happen. So variables created just before a new download could be mapped to register locations that already contain non-zero data, and existing variables may now be mapped to new register locations that do not contain the value of that variable prior to its download. This remapping needs to be managed by system designers to avoid these mismatches. There are a few ways this can be done in Cscape 9. For example, all register locations could be cleared prior to the download from the Cscape Tools menu. Another option is to utilize the setPoints feature so that some variables always contain the same value on a stop-to-run transition. For variables that must retain their value even through major program changes, these can be manually mapped instead. However, Cscape 10 eliminates these potential mismatches through a new download process. To take advantage of this new process in Cscape 10, you need to make sure that the firmware in your controller is up to date. The different firmware versions you need for each controller series are shown here on the screen. We will note that the X2 controller, as well as older generations of the XLE and XLT, are not supported with this new download process due to memory constraints. Now let's look at the improvements that have been made to the download process and variable handling for Cscape 10. The variable mapping process for Cscape 10 has not changed from Cscape 9. The same rules are followed here, where internal variables are mapped in the background. The first change that has been made is with the initialization of global variables. With Cscape 9, global variables strictly initialize based on their register location and the retained value of that specific register on power-up. Now with Cscape 10, the initial value column of the program variable window is now active. If you want a global variable to initialize to a specific value, then it can be plugged in by the user in the initial value column of the program variable window. So if a value has been specified in that column, the global variable will always initialize to that value. In Cscape 10, the default behavior of variables and their values after a download and on every run, transition, and power-up has changed. In Cscape 10, global variables that do not have a specified initial value will always initialize to 0. As well as this, the value mismatches that can happen with Cscape 9 can no longer happen with retained variables, as they will now always retain their previous value, regardless of whether or not the register it is mapped to by Cscape has changed since the last download. Retained variables created after the previous download will also always be initialized at 0. There have also been some changes made to the download dialog box that pops up every time a program download is initiated. You will now have two new options in this dialog box. On every download, the user has the ability to keep current values for all existing retained variables, which is the default behavior. Once again, when selecting this option in Cscape 10, you won't have any value mismatches from one download to the next. The second new choice clears all retained values. For example, you may want to do this if you are loading a new program onto a controller that has an existing program on it, and there is some overlap with the variable names between the two programs. Before we look at the next download improvement for Cscape 10, we will define what we mean by existing retained variables. A variable is only considered existing if its name, type, and dimension have not changed. So if you change the name of a variable, or for example, change the type from integer to double integer, or change the dimension of an array type variable from 16 to 32, it is now considered a new variable. Once again, all new variables are initialized on their first stop-to-run transition. Finally, we will look at global variable behavior and how we can adjust it in Cscape 10. To change the global variable behavior, you can select the Quick Menu button in the upper left corner of Cscape 10, and then select Settings. Then navigate to the Compiler Options tab, and you will find the options shown on the screen. The first option allows global variables to initialize upon entering run mode, which is the default. Once again, global variables with a value plugged into the initial value column of the program variable window will initialize to that value, otherwise they will initialize to 0. For the second option, all global variables initialize at 0 on every run transition, regardless of the initial value column in the program variable window. For the third option, global variables not mapped to %t are retained. This is not the recommended behavior, but is still an option. Finally, if you prefer for global variables to behave exactly as they did in Cscape 9, you can select the last option. This may be the ideal option for existing programs that were created in Cscape 9. To summarize the improvements to Cscape 10 for variable handling and program downloads, Cscape 10 eliminates all retained variable mismatches, a common issue with variable-based advanced ladder in Cscape 9. Cscape 10 also gives users the option to either retain or clear retained variables upon each program download. Finally, global variable handling has been enhanced by default. All global variables, regardless of type, are initialized on every run transition, and if you prefer a different behavior, you can easily adjust this in the compiler settings. That concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, so we continue our Cscape 10 webinars next week with graphics editing, as you can see on the page on the screen here. We do have a question about a firmware version available on site. I will check on that and I'll get back to you directly when we can get that up. Okay, other than that, we'll continue our Cscape 10 webinars over the next coming weeks. All the registration links are there if you wish to see those. Okay, thank you all very much, and we'll hope to see you again.